Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over polynomial operations. Our focus will be on how to multiply monomial by polynomials. We're going to be making use of the distributive property. This standard is covered in Algebra 1, 2, and Pre-Calculus courses. Don't forget, there are 15 practice problems at the end of this presentation that we'd like you to try out to demonstrate mastery of the material covered in this presentation. To gain access to the entire course list, just take a look at the links in the description below or visit our website at Mathgotserved.com. Alright, the instructions are as follows. For the problems that we're going to be doing, we are to simplify the following. Okay. Alright, so for question number 1, let's say we have the product of my monomial and binomial, x times the quantity 6x plus 2. Alright, so let's go ahead and do this. So in order to do this, we're going to be distributing this x in front into the terms in the parenthesis 6x plus 2. Okay, so remember the product property of exponents that we went over in the previous unit. We're going to be making use of it here. Okay, so let's determine what the power of each term is. So this x right here has a power of 1, and then this 6x has a power of 1. And imagine that this 2x right here has x to the power of 0, but you don't put it there. Okay, so what we're going to do is basically distribute this x to 6x. We're going to multiply that and then distribute x to 2. When we carry out the multiplication, remember, let's put that to the side, recall, when you multiply exponents with the same base, x to the a times x to the b, what do you do with the powers? You add the powers, x to the a plus b. That's what we're going to be implementing here, okay? So 6x times x to the 1 is going to be 6x, and then you add the powers, 1 plus 1 is 2. Plus, in this case, you have 2 times x to the 0, so you're just going to have 2. You multiply the coefficients. Imagine that there's a 1 here. You multiply 1 times 2, which is 2. And then x to the 1 times x to the 0 is 1 plus 0, which is just x to the first power. And you just write it as x. Okay, so there goes the answer to question number 1. Let's take a look at another example. What if we were to simplify negative 2a times 8a plus 3? We're going to be doing the same thing here. Solution is as follows. This negative 2a on the outside, we're going to be distributing it across the terms on the inside, namely 8a plus 3. Alright, so imagine that there's an a to the 0th power with the 3 here, okay? 2a has a power of 1, and 8a has a power of 1. So what you're going to do here is we're going to distribute negative 2a to the first power. We're going to distribute it to 8, and we'll also distribute it to 3. Alright, now when we're multiplying here, we'll multiply the coefficients. Negative 2 times 8 is negative 16. And then when you're multiplying exponents with the same base, you add the powers, a to the 1 plus 1. Okay, 1 plus 1, that's 2. Plus, oh wait, hold on. And then for the second distribution, minus times plus is minus. Okay, remember, anytime you multiply different signs, you always have a minus. Alrighty, 2 times 3 is 6. And then you have a to the 1 times a to the 0 is just a to the 1 plus 0, which is just 1. And there goes your answer for question number 2. Alright, let's try another example. Question 3, let's say we have to multiply v times 5v minus 9. Alright, we're going to be following the same procedure here. So v times v minus 5v minus 9, what we're going to do is we're going to distribute. Okay, we're going to distribute this v to 5v and also distribute the v to negative 9. Now the powers are as follows. V has a power of 1, 5v has a power of 1, and there's an invisible v to the 0 here. We don't have to put that, okay? All right, let's multiply. This has a coefficient of 1, so 1 times 5 is just 5. V to the first power times v to the first power, you add the powers, 1 plus 1, which is 2, minus 1 times 9 is 9, and then v to the 1 times v to the 0 is v to the 1 plus 0, which is just v to the 1, and you write that as v. Okay, you don't have to specify the power if it is 1. Okay, let's look at number 4. Number 4, what if we have 3y multiplied by y minus 4? Now the polynomial on the outside is 3y, and we're multiplying it by y minus 4. What's the simplified form of this going to be? All right, so we have 3y times y minus 4. Now there's a coefficient here of 1, invisible coefficient, and the power here is 1 also. The 3y has a power of 1. Now to multiply out, we're going to distribute, okay? So we're going to take 3y and distribute it to positive 1y and to negative 4. Okay? When we do the distribution, this is what's going to happen. If we do the distribution, we're going to have, let's see, 3 times 1 is just 3. Let's change the color. 3 times 1 is 3. And then when you multiply y to the first times y to the first is y to the 1 plus 1, which is 2. Minus 3 times 4 is 12. And then y to the 1 times the y to the 0 here is just y to the 1 plus 0, which is just y. And that's the answer to question number 4. All right, for question 5, what if we have to simplify the following? Negative 6n times n squared plus 3n. Let's take a look at that. So we're going to be distributing again. So we have negative 6n times n squared plus 3n. So this is negative 6. This has a power of 1, the invisible power. And n squared has a coefficient of 1. And then 3n has a power of 1 for the n. Alrighty? So what we're going to do now is we're going to distribute negative 6n to the first power. We're going to distribute it to n squared and 3n. Okay, let's do it. So negative 6n times n squared. Negative 6 times 1 is negative 6. N to the first times n to the second power is n to the, you add the power, is 1 plus 2, which is 3. Minus times plus, whenever you multiply different signs, you have a minus. 6 times 3 is 18. And then we have n to the 1 plus 1, which is 2. And that's the answer to question number 5. Alrighty, let's take a look at question number 6. So for question 6, let's say we are to simplify the following. We have 7y times 2y minus 1. Alright, so let's go ahead and simplify that. So we have 7y, that's a monomial we're going to be distributing across the binomial 2y minus 1. Let's go ahead and specify their powers. So 7y, this has an invisible power of 1. 2y has the invisible power of 1. And for the 1 right here, you have a y to the 0th power, which we do not have to put. Okay? All right, so what we're going to do now is we're going to proceed to distribute 7y across these two terms to 2y and to negative 1 y to the 0. When we carry out the distribution, we're going to have 7 times 2 multiply the coefficients, that's positive 14. And then y times y is just y squared because you're adding the powers. Okay? Minus 7y times 1, negative 7 times negative 1 is positive 7. And then y to the 1 times y to the 0 is y to the 1 plus 0, which is just y to the 1. And you write it as y. Alrighty, so that goes the answer to question number 6. Alright, let's take a look at 7. So for 7, let's say we have 2x. So we have a monomial. We're going to be multiplying it by a quadratic trinomial, 4x squared minus 2x plus 1. Alright, so how do we simplify a product of this nature? Well, we're going to follow exactly the same procedure. The only difference here is we're going to be distributing the monomial to 3 terms as opposed to 2 in the previous examples. Okay? Alright, so let's specify our powers. So 2x has an invisible power, x to the 1. This has a 1. And then this has an x to the 0. Alrighty? So we're going to take 2x to the first power, and we're going to distribute it to all 3 terms. The first term, the second term, and the third term. Okay? Alright, so let's do it. Multiply coefficients first. 2 times 4 is 8. And then for the variables, you add the powers. X to the 1 plus 2 is 3. Same procedure with the next term. 2 times negative 2 is negative 4. X to the 1 plus 1, add the powers, 2. Plus 2 times 1 is 2. X to the 1 times x to the 0 is x to the 0 plus 1, which is just x to the 1. And you write it as x. Okay, so that's the answer to question number 7. Alright, let's take a look at question 8. What if you were to simplify the polynomial product of 4z times z squared, let's make it z to the third minus 9z squared plus 3. Okay, let's go ahead and multiply this out. Alright, so we have 4z on the outside, and then we're multiplying that by z to the third minus 9z squared plus 3. Okay, so let's specify the powers for the variables. 4z has an invisible exponent of 1, and this z to the third z squared, and this has a z to the 0. Okay? Alright, let's go ahead and distribute. So we're distributing 4z to z to the third, negative 9z squared, and to 3. Let's go ahead and do it. Alright, so 4z times z to the third, there's the coefficient of z is just invisible coefficient of 1, okay? So 4 times 1 is 4. Z to the first times z to the third is z to the 1 plus 3, which is 4. Alright, moving along. To the middle term, positive 4 times negative 9 is negative 36. And then z to the first times z squared, you add the powers, is z to the third. And then lastly, 4 times 3 is 12, positive 12. And then z to the first times z to the 0th power is just z to the 0 plus 1, which is z to the 1. And you write it as just z. There goes the answer to question number 8. All right, let's take a look at number 9. So for number 9, let's say you're to multiply negative 5n squared with negative 2n to the third plus 3n plus 7. All right, let's go ahead and do that. This is how it's done. So we have negative 5n squared. That's a monomial that will be multiplying by the cubic trinomial, negative 2n to the third plus 3n plus 7. All right, so let's do it. This 3n here has a power of 1, okay? And then this is 7n to the 0. So what we're going to do is we're going to proceed to distribute negative 5n squared to the 3 terms of the cubic trinomial. Okay, so let's go ahead and do that. All right, so for the first one, negative 5n squared times negative 2n to the third. Minus times minus is plus. 5 times 2 is 10. So we have 10. For the variable n to the, you add the powers. Okay, 2 plus 3 is 5. Negative 5n squared times 3n. Minus times plus is minus. 5 times 3 is 15. N to the 1 plus 2 is 3. All right, and the last term, 5. Oh, we have a sign change here. So for the last term, we have negative 5 times positive 7. Okay, so if we have negative 5 times positive 7, minus times plus, different signs, you have a minus. Okay, 5 times 7 is 35. And then n squared times n to, there's an n to the 0 here, is going to be n to the 0 plus 2, which is n squared. Okay, so there goes the answer to question number 9. All right, moving along. All right, for number 10, what if we were to simplify the product w times 8w plus 3 and then add the resulting product with 6w. So this is a combination of multiplication and addition here. All right, so how do we do a problem like this? Well, let's see. So 8 times 8w times 8w plus 3 plus 6w. Now let's see, w has a power of 1 and a coefficient of 1, the invisible coefficient and powers. 8w has a power of 1, and 3 is a constant. It has a power of, it has a w to the 0 there. Okay, so let's go ahead and distribute. So w will be multiplied with 8w and 3. Let's do that. So 1 times 8 is 8. And then w to the 1 times w to the 1 is w to the 1 plus 1, which is 2. Okay. Plus w, so 1 times 3 is 3. And then w to the 1 times w to the 0 is w to the 1 plus 0, which is w to the 1 plus 6w. Okay. Now let's go ahead and combine like terms. Like terms are terms where the coefficients are either both rationals or irrationals, and the variables are identical with the same power. Okay, so if you look at this right here, 8w squared, there isn't any variable with a second power here, so 8w, you bring 8w down, 8w squared. These two terms are like terms, okay? Their coefficients are both rationals and their powers are both identical, as well as the variable. So we can combine these two. How do you combine like terms? Well, you just bring down the variable and you add or subtract and combine the coefficients, okay? So 3 plus 6 is 9, so it's going to be 9w. So the answer is 8w squared plus 9w as the answer to question number 10. All right, let's take a look at number 11. Question 11, what if we're to multiply f by 4f minus 7 minus 5f? Okay, so this is another example where we'll multiply and then combine like terms where applicable. Okay, so we have f times 4f minus 7 minus 5f. All right, so we have to multiply first, following the order of operations. F has a coefficient of 1. All right, and the power is 1 also. And then for f, it has a power of 1. 7 has f to the 0th power, okay? Now, what we're going to do is we're going to proceed to distribute 1f to the first power. We're going to distribute it to 4f and also distribute it to negative 7. All right, we're multiplying here. That's the operation. So we have 1 times 4 is 4. And then f to the first times f to the first, you add the powers, is 1 plus 1, which is 2. Minus 1 times negative 7 is negative 7. F to the first power. Oh, I don't have to put that there. So we could just leave it as 7f. Okay. Oh, yeah, we could put it. All right. And then minus 5f. The power of 5f, the variable, has a degree of 1. All right, are there like terms that we can combine here? So for f squared, this variable has a power of 2. There is no other term with that power. So bring it down. 4f squared. Now look at negative 7f and negative 5f. They are like terms, okay, because coefficients are both rationals and the variables are identical with the same degrees. So these two are like terms. We can combine those two. So when the signs are the same, you add and keep the sign. So the sign we're keeping is negative. 7 plus 5 is 12f. Okay? Remember, when you're adding or subtracting, you do not change the degree of the variable or the power. That changes only when you're multiplying two variables with identical bases and different or similar powers. Okay, multiplying exponents with the same base. Moving along, question number 12. So for problem 12, what if we have x squared times negative 6x plus 2 minus 9x squared? Alrighty, so how do we do a problem like this? So we have x squared times negative 6x plus 2 minus 9x squared. All right, let's specify variables and coefficients. For x squared, we have an invisible coefficient here of 1, and negative 6x has the power of 1. 2 has x to the 0 there. So what we're going to do is we're going to distribute x squared to negative 6x, and we'll also distribute it to positive 2. All right, so let's follow the rules of multiplication. 1 times negative 6 is negative 6. X squared times x to the 1 is x to the 2 plus 1, which is 3. Now distribute it into the second term. 1 times 2 is positive 2. And then x squared times x to the 0th power is x to the 0 plus 2, which is just 2, minus 9x squared. All right, so as we can see, these two terms are like terms. Coefficients are both rationals, variables are identical. And then they have the same degrees. Alrighty, so we'll just bring down 6x, negative 6x to the 3rd power. And then we are going to proceed to combine these two like terms, okay? So when we combine them, you subtract and keep the sign of the bigger one. So the bigger one is 9, so we'll keep the negative. 9 minus 2 is 7, so 7x squared. Answer is negative 6x to the 3rd. Minus 7x squared. Alrighty, moving along, let's take a look at question number 13. So for question 13, let's say we were to simplify 7b times 5b squared plus 1 minus 9b squared. Okay? All right, let's do it. So for this one, we're going to be distributing 7b into the quadratic binomial 5b squared plus 1. And then we'll combine the resulting product with 9b squared. Okay? All right, so let's go ahead and specify what the powers are if they are not clearly specified. So this is 5b to the 1, 2, and this is b to the 0 right here. So what we're going to do is take 7b and we are going to distribute it to 5b squared and positive 1. Okay, if we do that, we're going to have 7 times 5 is 35. B to the 2 plus 1 is 3. Now 7 times 1 is 7. B to the 1 times b to the 0 is just b to the 1. Alrighty, and then we have that minus 9b squared. Now, are there any like terms that can be combined? Coefficients are all rationals, good, but if you look at, the variables are the same, but the powers are different. So since the powers are different, we cannot combine it. So let's write it in standard form. So standard form just requires writing down the terms in descending order of degrees, okay? So the one with the highest power comes first. So 35b to the 3rd comes first, followed by the 2nd degree term, which is negative 9b squared. And then the last one is 7b. And there goes the answer to question number 13. All right, moving right along. For question 14, let's say we were to multiply 3m by 6m to the third minus 9 plus 10m. All right, so how do we do a problem like this? All right, so probably have a hang of it now, so let's do this one a little bit fast. So 3m times 6m to the third minus 9 plus 10m. All right, so you just distribute. We're going to distribute 3m to 6m to the third and negative 9. When you do that distribution, you are going to get 3 times 6 is 18. M times m to the third is m to the fourth. And then 3 times 9 is 27. And then m times m to the 0 is just m plus 10m. We have 18m to the fourth doesn't have any fourth degree variable term other than itself. The other two are both first degree terms in the variable m, which makes them like terms because their coefficients are rational. So we combine coefficients, negative 27 plus 10, subtract and keep the sign of the bigger, negative 10m. That's the answer to, oh wait, when we subtract it's not negative 10, it's actually negative 17, negative 17m. All right, so there goes the answer to question number 14, 18m to the fourth minus 17m. All right, last but not the least, number 15, and then we have some practice problems for you to do to test out your skills. What if we have negative 4d times d squared plus 4d minus 2d times d squared minus 7d. All right, so let's go ahead and do this one. All right, it's as follows. Let me put up a partition here so we don't mix up our work. Okay, so what we're doing is we have negative 4 d that is the monomial that we're going to be distributing it across d squared plus 4d. And then negative 2d, we're going to be distributing across d squared minus 7d. Okay, so don't forget when you're distributing, you also take the sign. All right, so negative 4d goes as a package when it's being distributed to these two terms. So when we do that, we have negative 4d to the third. And then negative 4d times positive 4d, that will be negative 4 times 4 is 16. The power is about 1, so 1 plus 1 is 2. So that's 16d to the second power. Okay? And then let's distribute the next one. Negative 2d times d squared, that will give us negative 2d to the third. That's the second distribution. We're distributing negative 2d across d squared and negative 7d. All right, so we'll do that first distribution. We get negative 2d to the third. Now negative 2d times negative 7d is going to give us positive 2 times 7 is 14d to the second power. Okay, now let's go ahead and combine like terms. We can combine 4d to the third and negative 2d to the third. Coefficients are both rationals, identical variables with the same degree, like terms. Combine them. Signs are the same, so you add the numbers and keep their sign, which is negative. So negative 6d to the third. Okay. And then if you look at the next pair of terms, this negative 16d and positive 14d, negative 16d squared and 14d squared are like terms because coefficients are both rationals and we have the same variable with identical powers. So we can combine those two. Negative 16 plus 4 signs are different. So you subtract and keep the sign of the bigger, which is negative. So it's negative 2d to the second power. Alrighty. So that goes the answer to question number 15. Alrighty, so these are the practice problems that we would like you to try. So we'd like you to try these. Now this is what we'd like you to do. Go ahead and pause the video presentation at this time and then solve all these 15 problems. So go here to simplify. When you're done, click back on the play button and then we're going to reveal what the answers to these problems are. Alrighty, hopefully you had a chance to try out the problems. The solutions are as follows. So for number one, the answer is let's make it in red. 5m squared plus 2m. For number two, the answer is negative 12d to the second power. Let's write that again. Negative 12d to the second power minus 5d. For number 3, the answer is 4z squared minus 10z. Number 4, the answer is 6a squared minus 18a. For number 5, the answer is negative 3c to the third minus 12c squared. Number 6, the answer is 15k squared minus 12k. Number 7, the answer is 20z to the third minus 5z squared plus 15z. That's for number 7. For number 8, the answer is 9b to the fourth minus 18b to the third plus 27b. Number 9, the answer is 12x to the fourth minus 12x to the third minus 8x squared. Number 10, the answer is 5q squared plus 4q. Number 11, the answer is 7h squared minus 7h. Number 12, the answer is negative 2a to the third minus a squared. Number 13, the answer is 16e to the third minus 6e squared plus 20e. Number 14, the answer is 18y to the third minus 20y. And then the last one, number 15, is a to the third minus 4a squared minus 12a. Alrighty, so there goes the answer to questions 1 to 15. How well did you do with these practice problems? Well, let us know in the comment section below. Are there any questions or clarifications that you would like us to make? Just specify it below and we'll be more than glad to assist. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of polynomials, do give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel. We upload videos to our page on a weekly basis, so don't forget to subscribe and hit the notification button. If you have any questions or comments, as indicated earlier, just include it in the comment section below and we'll be more than glad to support. More tools and resources can be found at our website, Mathgotserved.com, or just take a look at the link in the description below. Thanks again for watching and have a wonderful day. Goodbye.